All right. So our topic is deep dive into message queue in Spryker. As I believe everyone use queues in their development purposes or maybe some to resolving some business solutions. So queue is essential for resolving on different kind of problems if you're facing to scale your application to improve your performance or to perform some complex um, operations inside. So before going into deep, let me introduce myself. My name is Shadman, and I'm working as a solution architect in Spryker. And let's see how things will go. Okay, so this is our agenda. First thing will be an introduction, then we will discuss about queue, and then we will discuss about pub sync in Spryker, how we are using. Then we will discuss about benefits, then some real life scenarios which people face normally. And then we will jump into the configuration and how to set up our own publisher and subscriber in Spryker. After that, we will jump into the monitoring, how we can monitor queues, and then in the end, we will discuss about best practices that we can follow while using queues. Introduction. Uh, the primary focus of this session is message queues and real life complexities, how we can resolve those, discussing architecture and techniques, how we can use that in Spryker and to resolve our problems, and development, which also can help you to develop for development of high performance and scalable application. Okay, first thing before starting or jumping into the more detail, let me tell you in Spryker, we are using queues. We use to make things, to perform some asynchronous task. Um, Normally, when we supposed to use, if we are facing some complex logics or some complex operations, then we normally use queues in order to process those complex logics in the background. And it also supports the large volume of messages if you are having such scenarios where you are facing some millions of records. That also helps you to resolve that in asynchronous mode. Beside this, we can also, it helps you to optimize your resource utilization and enhance scalability, because everything will be async, and you can process your messages or process your operations, perform your operations in the background, which you can scale, and which also helps you to increase your performance for the end user. In Spryker, we are using RabbitMQ as a default message broker. Okay. First thing, from Spryker perspective, we are using publish and synchronization in Spryker. In publish and synchronization, this is actually a mechanism where we are using our queues, but this is not important. You just use queues over here. You can utilize queues in any operations, whatever you want, in order to resolve your issues on daily basis. But the thing is, like in Spryker, mainly we are using in publish and synchronization process. First thing, which is very important to understand, like we have two things, main things, like backend as well as our front end. So if we talk about front end side, we are using Eves and Glue APIs for interfaces you can use for to integrate any other application. So for that purpose, we are not using directly, we are not hitting directly to our database. We are using Redis and Elasticsearch instead. But for back office operations, for backend operations, we directly using relational database. So this is something where we are using publish and synchronization in order to update your front-end storage by the help of queue mechanism. So this publish and synchronization process is isolated with two different processes. First thing is publishing, and another one is synchronization. What publishing is doing, it's actually converting your data or making your data suitable for from normalized data to a suitable format which Elasticsearch and Redis can use. This is something where we are just formatting our data. for Elasticsearch and Redis. But the second process, which is synchronization will pull that data from the database where we have placed after formatting, and then we actually write into the Redis and Elasticsearch. If you see the diagram, this actually can help you to understand how things are working inside in publish and synchronization. So the main points are storefront, all right, and the back office. Back office is using database directly because we have to perform different operations, and storefronts is using Elasticsearch and Redis. It depends upon your requirement. Either you wanted to use Elasticsearch or you wanted to use Redis. It's up to you. Because Elasticsearch is using mainly we are using for search purposes. Redis is for other kind of data. So as we are not directly hitting to the database, because we wanted to improve our performance and usability of our users, so we are using this layer. But in order to update this layer, we have from the database, like first source, first primary source is database, and another one is Elasticsearch or maybe Redis. So in order to make things updated for the front end side, we have to introduce some mechanism over here. So this mechanism is isolated with two processes. One is publishing and another one is synchronization. Okay, so first step, if you change something or if you create something, just an example in back office, so it saves into the database. Then it actually it triggered the event. In that event, we actually save the message in the queue, like this or this record has been updated or this record has been created. Once we get a message in the queue, we process that message in the publish service, publish layer, and then we actually save into the database. Once we have that published data into the database with formatted, which will be suited for Redis and Elasticsearch, then we trigger the operation of synchronization with the help of queues. By that, we updated Elasticsearch or maybe Redis. It depends upon the request. Then we can use, in our storefront, either it is Glue API or maybe use. Second thing, benefits of queues. So which is before jumping into the integration part, I believe like everyone wanted to know like what are the main benefits of queues, why we are using queues. Okay, first thing is performance. You can process your other task without interruption. You can process your task in the background asynchronous mode, which can improve your performance, as well as give you a faster response time for your customers. Because if there is any complex logic you wanted to process before, if you process on the front end side or maybe on the runtime for the customer on their request, probably it will take longer to process and then respond. But if we are introducing a queue, this will actually give you a performance boost, because your main heavy operations will be in the asynchronization mode. Scalability. If you have if you have increased volume of request, which probably you will get after expansions of your business, so time to time you will get lots of data in place. Sometimes this is actually a requirement to import or export, something like that. All right, so the thing is like it will increase your volume of request and give you an opportunity to process those in asynchronous mode. If we talk about flexibility, as we are using queues, so we can perform our communication of different components in asynchronization mode by the help of queues. This gives you, this helps you to decouple your components separately and communicate between them through the queue. Separation of concerns between different components, as every component will be independent and decoupled. So it enables you to introduce separation of concerns between different components and communicate along with the queue by the help of queues. Fault tolerance, if we talk about it, actually in fault tolerance, you cannot lose your data, because if you're handling a request on runtime, then probably your you already have lots of requests in parallel, maybe you lose some data, or maybe your application get crashed. But the thing is, like, if you're using queues, your request will be in the queue. It has retry mechanism, it has reschedule processes, and it can handle your error or failures gracefully without impacting your usability actually. Load balancing can distribute workloads across different components, because we are having queues, and we will have multiple workers in order to perform your request into by the help of multiple workers. Okay, some scenarios and possible solutions which we normally face. First scenario, which is data import by queues. Okay, imagine like you have a system with large number of products and multiple suppliers. You need to fetch the product information from the external APIs and transforming the data and saving into the database. All operations are synchronized, and the application is tightly coupled with, you know, with the process of the application flow, the import flow and application flow. It probably it is giving you a block. It is blocking your application just because of slow response time, memory intensive operations, poor user experience maybe. And manager, if you are going to manage retries and errors, it would be very difficult for you because everything is sync. Whenever you get a request, if you cannot fulfill that request, probably you will, you know, lose that request. So possible challenges would be slow response time, error handling, and scalability. So how we can cover those? By implementing a queue-based approach. This is actually a possible solution for this problem. By this, we are going to introduce a message queue, just like RabbitMQ, which can decouple your import operations from the main flow. Instead of sending a message to the application and processing on the runtime, we are processing in the background, and we can import our data asynchronously. So this can easily help you to resolve these kind of scenarios. If we see the diagram, just to have a clear picture for everyone, first scenario, this is actually a diagram of scenario. What we have, this is a data source, and if we are importing data to the database, it will be look like that. Data reader is can be transform your input into source. This steps is a collection of the steps to enrich and transform a record into source. And write operation is simply pass the record into the persisting mechanism, like Propel. In Spryker, we are using Propel ORM. So this is actually something which is in Spryker, but the thing is, like, it is representing you a regular data import. But if we talk about queues, so in queues, we are distributing our load, right? So if we are sending data into the queue, we cannot send data directly to the queue because it is not public, or you cannot access from outside the network. So this is actually back office API. You have to push into the back office API, and it will send those requests to the queue. And same operation will happen in the workers, and we will save into the database. So if you notice, we have chunks over here. In chunks, we are using, we can handle, you know, lots of messages. Like by default, we are using like 200 chunks and per process. So this actually can help you to reduce or process your messages as soon as, you know, you will get it in the front end side. But if you talk about current scenario, we are sending, you know, messages, and if we will have lots of messages, probably your application maybe will be crashed or maybe something like that. Probably like it will consume lots of memory. So this can break your application for end users. So this is actually can help you to understand like how queue can help, and by using chunks and by using multiple workers. All right. The second scenario, which is introducing multi-queue publish to optimize for performance for increasing volumes. So our scenario is here, like we are using single queue. Okay. For prices, for product, for categories, we are just using a single queue. And we will have a high volume of product updates from a supplier. Okay, hundred of products are updated, including product changes, information changes like stock, product description, maybe prices. Everything is in the queue, and we are having hundreds of thousands of products. Okay, due to high volume of updates, probably performance can impact it, and update can take long time to process, which leads to delay for your processes, right? Like if you wanted to upload thousands of records for product prices and catalog, but on front end side, same time on front end side, if you're expecting your updates should be replicated on a very short period of time, it will never happen, because we have to process one queues one by one, or maybe in chunks, or maybe time to time, but it will take longer to process. So for this problem, we have multi-queue publish approach. Okay, in this, by the help of this approach, we are using different queues for different processes. Like we will have different queue for prices, different queue for category, different queue for product, different queue for product availability. So everything will have different queue. Everything for every process will happen parallel. Like product will not interact category will not interact with price process. Okay, and this also helps you to debug your errors, because if you just have a one queue, and you will have hundreds of requests in just one queue, and then it will be really hard for you to debug, like if you are facing some challenges or some problems or some issues. But if you have multiple queues, then you can easily resolve your problems by debugging that. Also, there is another problem in single queue, like if you are using one queue for products, prices, and categories, for example, and you get exception in categories, it will not allow you to process other messages. It will break. It will be stuck. So, but if you talk about multiple queues, so if category process got stuck just because of any reason, it will not impact your product queue. So this is another scenario which can help you. Okay, so this is actually a diagram. By this, we can easily understand how things are working over here. This is scenario. We have prices. Oh, sorry. We have product. We have prices. Okay. We have just one queue, and error queue and retry queue we actually provide with every queue in this Spryker. So this is something you guys can understand it. All right, so event queue, whenever we push something into the queue, it will process one by one and will push to the process, like product process and price process, but we are using a single queue. Similarly, if we have multiple queues for them, like price will have a separate queue, product will have a separate queue, and we are using 200 as a chunk size, and it will process your queues 100 by 100, or you can say 200 will take 200, will take 100. What is the benefit of chunk size? Like if you're processing one queue at a time, it will execute, let's suppose, 3 queries to complete your process. But if you're using chunk size, it will, like 100, it will grab 100 messages and then process all together. So it will reduce your number of queries, but you have to be very take care. You have to be very take care of it. This number, it should be balanced. Like you should not increase like 1,000 or 2,000, because it will probably reduce your performance. Because if you're processing lots of messages at the same time, it definitely will impact your performance. So here in this configuration, chunk size, you should be balanced, like how many numbers your processor or your application can take care of it easily. Also, we have a retry mechanism. Like if we are getting errors, we will push into the error queue for product. Similarly, we have error queue for prices. So everything will be managed separately, and this will help you to debug your problems and understand things if something goes wrong. Okay, now let's jump into the configuration of queue. How, if I'm going to use a queue, how I can configure in this how configurations are working. First thing, you need two packages. First is Spryker Q and RabbitMQ. But luckily, you have both packages in demo shop. So if you are going to use demo shop, you will get both by default. So this is actually a configuration. In config shared config default file, you will see the queue configuration. Here where you can configure your adapter. Right now we are using RabbitMQ, which is default. Spryker supports by default. In the same file, we have some other configuration, which is connection of RabbitMQ. Okay, and if you have defined your connections in the environment file, it will grab from here. This one is default connection. You can use multiple RabbitMQ connections even as well. Like if you wanted to use one connection or one RabbitMQ for um, Germany DE store, if you wanted to use another RabbitMQ for US store, so you also can do that. So this is actually a RabbitMQ configuration. We have a for loop, and we are actually placing stores and with the configuration along with the default configuration. Like sometimes people wanted to use just one RabbitMQ for all stores, so this is also can happen. Also, you can override those configurations by just using store this one, like associated array, like DEE. This is for DE array. This is for DE store, and you can override these configurations what we have just discussed. So this is actually a very simple configuration which you can use if you're going to configure your own RabbitMQ separate connection, or if you wanted to change something over there. Okay, now time to introduce a publisher and subscriber. Okay, first thing would like to mention, don't mix publisher, subscriber, publish and sync. Publish and sync is a different process. It's a mechanism in Spryker which actually sync your database with the Redis or Elasticsearch storage. This is just a publish and synchronization process. But this is a publish subscriber. This is a normal, common process which we normally use with the queue. One, we will have a publisher, another side we will have a subscriber. If we, send some message into the queue from the publisher, subscriber will take care of it and process that message. So this is something like that. So before jumping into that, here in this introduction of publisher and subscriber in Spryker, we are going to introduce a new queue for our requirement, custom personal requirement, custom requirement, you can say, and we will see like how we can introduce it. Okay, before starting in introduction, introducing a new queue, first let's discuss about trigger part, how we trigger our events. We have two, what you can say, like we have two ways to trigger some events. One is by Propel behavior. Propel we are using as ORM in Spryker. We have behaviors over here. If you see here, this is actually a schema file. In a schema file, you can define your behavior, like event name and some parameter if you wanted. And this parameter representing like you are executing for all operations like create, delete, or update. This represents a column. If change happens in any column, it will trigger. So in this example, or you can say, we can see here some events: create, update, and delete. This process, this attributes, or you can say these parameters will trigger these events just because of all. All right. Similarly, we can use for different columns and other options as like for just for delete purposes. So there are lots of documentation available for Propel behaviors which you can follow. The other way is trigger event manually. In Spryker, we also have an option to trigger your events manually by the help of just one line. If you just see an example, this is a queue name, right over here, and this is an ID of the record that we wanted to process. So this is and we are calling event facade over here just to trigger an event. Okay, now after knowing about how we can trigger events, let's start to introduce a publisher and subscriber. So here, as we already discussed, we had two approaches. First is by behavior of Propel, and another one is manual. In this example, we are considering Propel behavior. Okay. So this is actually in example. Okay, what we are going to do, we have already a table, we have already a process in place, but we wanted to add a event which will be triggered and which will be processed in the background by the help of subscriber, and we will perform some operations over there. So as this is actually existing table, now what we are doing, we are just adding these lines just for an example. Okay, this is an event name, and this is the same thing, behavior name, and this is actually a static behavior. Okay, now we have defined an event where we wanted to trigger, but in application level, we have to define those events. So what we are doing, we are extending bundle config, abstract bundle config, and we are using Antelope configuration. Antelope is our module where we have created a configuration file and defined our events what we are going to use. We are in our example, we are using create, update, and delete. After adding events, we have to introduce a queue, right? Because we are going to use a queue in our process. So we are defining our queue in the same file where we have defined the events. Next thing, once we define a queue, we have to let RabbitMQ know like we have a new queue in place, which we wanted to use. So you just need to add in the RabbitMQ configuration. So in first step, what we did, we just introduce an event and define in the Propel behavior. And in second step, we have introduced a queue and added in the RabbitMQ configuration. Third thing will be publisher. Okay, so this publisher, which is using publisher plugin interface. Okay, we have a method, subscribed events method. This event method will be responsible to trigger this function. Will responsible to execute in these events, create, update, and delete. Whenever these events will be triggered, this process will be triggered and push message whatever we have done into the queue. Similarly, once we have pushed our data into the queue, now we have to define our subscriber. Okay, let me repeat what we have done. First, we have defined event and behavior, and in second, we have defined queue, and then we have defined our queue publisher. Now it's time to define our subscriber. Subscriber is here. We have implemented an interface which is queue message processor plugin, and we have defined chunks inside, like how many messages you wanted to execute on one time. So this is a definition, and this is something where you have put your logic whenever this subscriber will get executed. So this is just an example. All right. After having a subscriber in place or processor plugin, we have to add this into our dependency provider. By this, see, this is a queue name, and we have defined our dependency provider over here. plugin processor plugin, and this will process. This will execute this process. After having a subscriber in place, now if we have already executed a scheduler in the background, or if we have not done yet, so we can also execute that execute this queue in order to process your message. So this is a command which can help you to execute it. This is actually helps you to listen the queue. If we have got something in the queue, it will process it. Okay, let's recap what we have done. We had a module. Okay, we have done some changes, create or maybe update into the database table, which is Antelope. Proper behavior will get triggered. Okay, and event message will be pushed into the queue. Once we get a message into the queue, our subscriber or listener will listen about the message, and will get processed. Once you get processed, so this is actually something which is representing just a process. So if I go back, so this is the line where you can perform your process. Okay. Monitor next thing is monitor queues in Spryker. Okay, as we are using RabbitMQ by default in the Spryker, so we are also providing monitoring dashboard in the RabbitMQ. I believe many of you are already aware about that, like how RabbitMQ dashboard works or what RabbitMQ is providing us. So this is something. Let me explain you. Here you can see or monitor your queued messages. How many messages you have in the queue, and what is the processing time, and how many how much system is utilized, memory, disk space, everything will be here. Similarly, like how many connections we have, how many queues we have, you can also see in the dashboard side. And if you jump into the queue, you can see all queues are here. As I mentioned you earlier, like we can have multiple queues for different processes, like publish, price, product, category. We can have multiple queues. So this is showing you an example, like publish and sync. Publish is a separate process. Sync is separate process. So we are using queues on both processes, like product abstract, price, product abstract. So these are all queues which are separated out. Also, you can see here which queue is idle, which queue is running, and how queues are performing. And if you notice, here we are using AT Docker and DE Docker in the virtual host. So AT is representing another store, and DE is representing another store. So in this with the default configuration of Spryker Demo Shop, we are using two stores. We have two stores, AT and DE, and in both the stores we are using different queues inside. Similarly, if you go into the more detail for the price product abstract, this is just an example. You can pick any queue from the list. So you also can see more details of the queue, specific queue, like what is the message rates we have in a couple of hours, in a couple of minutes, how many messages queued in the queue. Similarly, what is actually the performance over here. Also, we have a package New Relic RabbitMQ agent, which actually support you to add RabbitMQ dashboard into the New Relic site, which also can allow you to have monitoring dashboard or monitoring site in just one place. Okay, let's talk about best practices. Okay, so I know like we have lots of best practices, like not usually normal people follow, but these are some specific which we are discussing here. You can say very common, which we supposed to follow. First thing, data handle errors. We have to implement proper error handling to manage our failures and errors. We have dead letter queue and exponential back off retries in this queue, which actually supports you to make things more better in sense of error handling. Second thing, proper queue configuration. We should consider to configure queue properly, like maximum number of retries, chunk size, optimize the performance of the queue, which actually give you more performance or maybe a better results, if you are configuring it properly. Monitor queue metrics, as we have built-in monitoring and logging, you can use in order to find your problems and insights and queue performance and health. Next thing is security best practices. You have to be ensure like everything is secure. If you're using RabbitMQ UI, it should be secure. If you're using, there should be authentication mechanism, or the data, cannot be compromised. You can have regular audits as well on that. Scale queue consumers. Okay, so this is something which is very important to understand. Like if we have a queue and we have consumer, but sometimes we think about it like uh, we have to increase the number of workers. Maybe we have to perform our messages uh, quickly, but we can do that. But the thing is, like, you have some kind of trade-off over here. Like if you increase your workers like 2 or 3, maybe it is fine for you. But if you are going to increase the workers to 100 or maybe 50 with 200 chunk sizes at a time, so probably instead of giving you a better performance, it will give you a bad performance. So it is something we have to understand it clearly. Like we need to configure as per our need, uh, and after having a better analysis, how we can balance this. This last thing is queue size in check. You have to monitor your queues time to time. Um, it should not be uncontrollable, which can help you to understand your system health as well, how system are performing. So you have to check time to time.